Hello, everybody. This is our instructional bit on hyperbolas. We're going to talk a little bit about the anatomy, quote unquote, of a hyperbola, and we're going to talk about the things I'm going to expect from you when it comes to graphing these things. If you look on page 1 of the notes I posted, the Blackboard, you will see that picture we've looked at a bunch of times. It's like a picture of a double cone, and it's being cut by planes in various angles. We saw before that A was the circle, B is an ellipse, C is a parabola, and we're going to talk about the last one today, D, which is the hyperbola. That's the one where the angle of the plane is in between that of the it's sharper than the angle of a parabola, and it means that it hits the cone twice. So you get these two branches. So that's what D is on that picture. If you look on the next page, you'll see some things, just some kind of vocab words for the hyperbola. We got vertex, center, the branches, transverse and conjugate axes, and the asymptotes. One thing I didn't put on there is foci. So if you have a pencil or you're thinking about it, you could write that down there as well. I'm going to ask you to find all those things. Really, branches, transverse, and conjugate axes are just terms I'm going to use. I want you to be aware that those are there. I'm not going to ask you to find those. So to identify what all those vocab words mean, we're just going to look at a hyperbola. We're going to look at two. We're going to look at one that looks like this, where you can see the branches open left and right, and one here where the branches open up and down. A hyperbola like this, where the branches open left and right, the general equation is this: x minus h squared over a squared minus y minus k squared over b squared equals 1. You can see that the big difference between this and an ellipse, they look very, very similar, is that the sign in between the two square terms is a negative. And this one opens left and right, which means, and you can tell that from the equation it's going to do that because the x squared term is the positive one. X minus h squared is the positive term, opens left and right. Y minus k squared is negative. You might have guessed that on this one, you're going to have, it's going to look like this: y minus k squared over a squared minus x minus h squared over b squared equals 1. Again, y squared is positive, therefore it opens up and down. X minus h squared is negative, opens up and down. The center of the hyperbola is this line. You imagine there's a line that goes right through here, right through, it crosses both branches. This line is called transverse axis. It's only important that you know that because I'm going to use that word, I'm going to reference it again, so I want you to know what I'm talking about. The transverse axis is the one that goes through the center and crosses both branches of the hyperbola. The conjugate axis is parallel to that one. That's right here. The conjugate axis. Again, these are just words I want you to know. It's not vastly important. I'm not going to necessarily ask you to find the conjugate axis, the transverse axis, but I want you to know what they are. For a hyperbola that opens up and down, the transverse axis is going to be a vertical line, like this. And the conjugate axis is going to be this one that goes side to side. The place where the conjugate and transverse axes intersect, right here, is called the center of the hyperbola. And for the ones I'm going to ask you to graph, the center is always going to be 0, 0. That's just going to make it easier. You'll get all the important points about graphing these things, but it makes writing the equation of the asymptotes a lot easier, so we're just going to worry about ones that are centered at 0, 0. For those, what that means is that h and k will both be 0. So you'll end up with your equations will look like this: x squared over a squared minus y squared over b squared equals 1. For the rest of this video, I'm just going to work on this one, and everything that I'm going to say transfers directly over to the ones that are vertically oriented, the ones that open up and down. The only difference is that the y squared term is positive here. The x squared term is positive here. So I'm going to erase this so that I have a little more room to write. I apologize for the freakiness of the board. That's just the way that is right now. So we have the center, conjugate, and transverse axes. Here's our kind of our generic equation of these things. And the way that we're gonna, well, let me just identify the other two things. The other two things to identify are the locations of the vertices, the asymptotes, and the foci. So there's 3 more things to identify. So actually, we'll talk about the asymptotes in the next video when we talk about graphing. So the vertices, they're the points on the hyperbola where it crosses the transverse axis. So that's going to be this point here, this point, and this point. These are going to be the vertices right here and right here. And the way you find them is you go a distance a from the center along the transverse axis. So this distance right here is A, and this distance right here is A. My picture is imperfect, but you can forgive me for that. And since these are always going to be centered at the origin, the equations of the vertices are going to be plus or minus A comma 0. Or if it's a vertically oriented one, this is for, I'll call this a horizontal transverse axis. But if it's a vertical one, as in it opens up and down, you're going to have 0 plus or minus A. Because you're going to be going up and down and find the vertices. So that's how you find the vertices of these things. And this is a little clear when we start doing practice problems. I'll do a couple of those, but this is how you find those. And then the foci, similar to an ellipse. With an ellipse, the foci were always inside the ellipse, and with a parabola, the focus was always like inside the curve of the parabola. Similarly, for hyperbola, the vertices are going to be like over here, like inside the curve of the hyperbola. So there's going to be a focus there, and there's going to be a focus there. And the question is, how far from the center do we move along the transverse axis to get to the center? And just like with ellipses, there's another number c, which we find using A and B. If you recall, with ellipses, we said c squared was a squared minus b squared. But for a hyperbola, c squared is a squared plus b squared. This is like looks like the Pythagorean theorem, and it's related to that. But for now, we're just going to think about this. And this will get you, you can get c from this equation. Whatever a squared is and b squared is, you add them together. And then to find c, you take the square root of that sum. And the way that we find these is we would then move c units this way and c units that way, again, along this transverse axis. So I'm going to have the distance here, which we call c, and the distance here, which is also c. And c needs to be bigger than a, otherwise it's not going to be in the right spot. So if you're trying to solve one of these and you get c is smaller than a, it means you probably subtracted here or something, so don't do that. And the equations of the foci are going to be plus or minus C0, because it's going to be like, I go C units to the left, that's negative C0. C units to the right, that's positive C0. That gives me these 2 points. And just like with the vertices, if the transverse axis of the hyperbola is vertical, you're going to have 0 plus or minus C. So I'm going to stop this video here, and we will talk very briefly. I'll post a short one about how to find the asymptotes next, and then I'll do a couple practice problems.